Okay, before we get started, I just wanted to thank Women Who Code organizers for putting this together. It's been a really nice night, and it's been really nice to meet all of you so far. So thank you. And thank you, Mercari, for hosting us. The space is really beautiful.
Thank you so much.
Okay, I want you to take your phones out and hold them in your hands. Can you do that? Everybody? Everybody, take your phones out. All right, now pass your phone to the nearest person to you and swap. You can do it. Okay, you've got a phone in your hands, look at it, feel the weight of it, right, and the texture. But you almost can't do that because you're thinking about your phone in someone else's hands. It's so uncomfortable. Okay, you can pass them back now. The reason we feel this way is that we live our lives increasingly online. Everything that we do, all of these parts of our person are now parts of this digital structure. And in handing this, weight of a metal object to someone else, you actually feel very exposed. It's not just a metal object, it's actually an extension of yourself. So Pete Smart talks about this when he talks about human-computer interactions, and he talks about devices a lot. And we're going to talk about human-computer interaction a lot today too, but with less focus on the device and more focus on how these systems governing our lives can impact the way that we think about our lives and the way that they touch others. So there's a lot of different takes on living our lives increasingly online. And if you're in this room, the chances are, as we lived more and more digitally, you got excited. You thought the more and more we lived our lives online, the more you thought, what can we build? What can we make? What can we do? And that's really, really exciting. So some of you might have started with, GeoCities, which is pretty much the best part of the internet. We hit the best part of the internet right away and peaked then. We peaked in high school and it's all been downhill from here. No, I'm just kidding. But it was kind of a bastion of GIF and crazy explosion. Then we had MySpace, where everyone was friends with Tom. And actually, in putting this talk together, I revisited mine, which was like a time capsule of terrible art and, terrible bangs, my old art pieces, and photos of me in a bathroom. I don't know, it was like a face or something. Some of you might have started with Dragon Ball Z. Dragon Ball Z allowed you to customize your page, so a lot of people started coding by customizing a Dragon Ball Z page. And some of us started because we wanted to be elite hackers, so good at programming that our fingers were literally on fire and smoke was billowing out of our computer. But whatever our interests are, and however we express ourselves online, in the most creative, bizarre, and unique ways that only a collectivity of humans could possibly imagine. But the only constant is change. And soon we had so many ways of being represented online, and so many people were online that we had to figure out systems to build, tag, and sort for us. But the more complicated things got, what we started to realize is that we're summations of digital models. We're parts of other people's algorithms, and we can be summarized in a single way. People are using search engines rather than libraries or teachers to make sense of the world that we're inhabiting. These inaccuracies start showing off and being reflected in what we learn and what we believe in. They become our societies and our education. And tech can be magical this way, but just like any kind of technology that's magical that you can't see into, it can also be abused. I'm Sarah Drasner. I'm known on Twitter as Sarah Edo, and I work for Microsoft. I work for the developer advocates who sponsored Tonight We're Hiring in Japan. And I also am a staff writer for CSS Tricks and WWCode team member, which is what brought me here now. And today we're talking about live and machine learn. In this talk, we're going to talk about a paradigm shift that machine learning can bring. So first, we're going to talk on a very high level about how machine learning works. And then things are going to get dark here as we kind of explore some of the ways that it's been abused and mishandled. But don't worry, we're going to also talk about machine learning for good. And then we're also going to talk about things that you can do in technology to kind of make the world an easier place to live in for all of us, and just web applications in general. So before we talk about on a high level about what machine learning is, let's kick it off with a quote by the guy who coined the term machine learning. Machine learning gives computers the ability to learn without being explicitly programmed. So okay, we're programmers. We're familiar with if-then statements. But what if the conditions for the if-then statements get complicated? And I mean really complicated. So if you're trying to build a program that knows that this is a pug and this is a kitten, you don't necessarily want to program an if statement for every single pixel here, plus the possibility for every configuration of every pug photo. I mean, that's not really how our brains work, right? So how do you program it? Well, you want to teach it a certain pugliness. You want to teach it to learn the essence of the pug. So in truth, there are a few ways of doing this. Sometimes, like in the example above, you can tag a set of data and your model will learn that these are pugs and these are kittens. This is a supervised data set to distinguish between these classes and help it learn better. So this is called supervised machine learning. But other times we don't know the answer. So if I asked a computer what these pugs would look like if they were bred with a stegosaurus, well, that's not really a thing, right? So if we have to do that kind of analysis, we use what's called an unsupervised process. Let's dive into supervised processes because in the time that we have, they're a little bit easier to understand. Unsupervised processes are a bit more complicated, and they're pretty common as well. And in truth, actually, even within machine learning, there's literally thousands of algorithms you could use. And we actually saw one earlier tonight with the scikit, yeah. So of these, convolutional neural networks are the most popular, so that's the one that you'll see out in the wild the most, but genetic is kind of the easiest to understand, so we're gonna dive into genetic as an example. So let's explore a simple toy model. We have a pug-kitten sorter, and first we build an algorithm that builds algorithms. It'll build many of these, and they'll set out to do their best sorting. And at first, they're bad at it, like really bad. Not just bad, but they're terrible. But we've built another function to check this. It will take some tag data and check if it's indeed a pug or a kitten for every scenario, and the ones that get it wrong are thrown away. The ones that get it right are circled back to the builder. And then we build more off of what's successful. Now, this might seem hacky and imperfect, and that's because it is, but we don't do this a small amount of times. If we did it once, twice, or 3 times, it would fail, but we do it thousands of times, and it ends up being pretty good at it by the end. And we don't have a small amount of conditions either. We build up all the gradients that make up an eye, then we match this against other eyes, then we match that against the likelihood of snouts. And in fact, our own classification system of animals, genus, kingdom, phylum, is a small and human comprehensible system composed of these types of rules. But the part I want you to remember is this going forward. That part where we check, you can see how that's a really important part of all of this. If we have the ability to get the data right, if we have the ability to get the data right, we must do so and keep on checking. Another really important part of this is the data that's fed. If these were the pug pictures it was trained on, that would be correct, right? These are pugs. But it might fail in a test to find the one true pug. And the type of data that we train on is really vital to the accuracy of the answer that we're seeking. So let's talk about some ways that this has failed in the past as kind of a cautionary tale. And I'm calling this section, "The Road to Hell is Paved with Good Intentions," because none of these were started off trying to be horrible systems or destroy society or something. Quite the opposite. All of these are really well-meaning systems that have failed because of the processes, so it's important that we evaluate them. So let's say you need to patrol a city for crime, but you don't have enough units to cover the whole space completely. So it might make sense to figure out where all of the crime is happening and have some patrol units focus just on the areas with most activity. But the problem is not all crime is created equal. So to get enough data to get an idea, you have to include nuisance crimes in which no one's hurt, like homelessness and panhandling, with the violent crimes like rape and murder. But rape and murder aren't clustered in this way. It takes a lot more data to build up an area, and that's why the nuisance data is entered, because they need more data. But the problem with that is that the nuisance areas tend to be poorer areas, which lead to more policing, and then you have more data on the poorer areas as well, so it gets into a feedback loop. And then it starts to become blind to the rape and murder in other areas. This is a really big issue. It means that affluent areas, you don't see those crimes anymore. You only see them in poorer areas. And this is what the software PredPol does, which we use in the United States. And it's an example of bias sample in machine learning. That's like when we saw the pugs with the lion heads. It's poor data association, so it keeps feeding back into a bad loop. And another problem with this is that once you're in the system as a criminal, you're more likely to actually do more things that cause crimes. 68% become reoffenders within 3 years, 77% in 5 years, and part of the reason is that people report finding it hard to fit back into normal society once they're inside prison. So what you have is this kind of cycle. The other part is that employment becomes more difficult. In the United States, if you have committed a crime and if you've been to jail, you have to report that on your employment forms, and then people are less likely to hire you. Being employed is the #1 indicator for whether or not you're going to commit a crime or not. So that becomes a non-virtuous cycle. And even our analysis of who ends up in the system uses machine learning. So when most defendants are booked to jail, they respond to a compass questionnaire, and this is fed into a system that evaluates high risk level for criminals and is used in the length of their sentencing. In an evaluation of more than 10,000 people who were analyzed by Compass over a 2-year period, they found that risk scores showed a pretty startling difference. So Black defendants would have scores fairly evenly matched across the board, 1 meaning no risk, and 10 meaning that they would have a very long sentence because they had high risk of reoccurring offenses, whereas the white risk assessments look quite different. Many are assessed at 1, steadily decreasing to 10. But what if that's just valid data, you might ask? Turns out it's not. The study showed that Blacks were twice as likely to be labeled higher risk and not reoffend, while their white counterparts were labeled not as risky as they were by a lot. So this is a really big problem, is that these machine learning analysis can sometimes become a black box and reflect our own biases. So if you look at some of the Compass scores that we have here, 2 shoplifting arrests, James Ravelli low risk at 3, Robert Cannon medium risk at 2, James Ravelli prior offenses, 1 domestic violence aggravated assault, 1 grand theft, 1 petty theft, 1 drug trafficking, and he subsequently reoffended. Robert Cannon had 1 petty theft, evaluated at 6, and no subsequent reoffenses. 2 DUIs, for 1, 3 DUI, 1 battery, and subsequently 1 domestic violence. Mallory Williams, 2 misdemeanors and no subsequent offenses, and their risk scores are 1 and 6. And I could keep going on. There's tons of reports like this. And these kind of algorithms don't only affect Black people. Zilli was a construction worker who stole a piece of equipment and sold it for parts because he was really low on cash and didn't have money to eat. Since he was in jail, he came out and he's been involved in church events, he's volunteering, he's doing all of these things to help mentor and help others, but that doesn't reflect his score at all. His score doesn't change even if he shows that he's made progress. So what makes Compass fail? The book Weapons of Mass Destruction covers some of these key tenets. It has no transparency. It means that they created this thing and then nobody reevaluated it. It just kind of went out into the world. And remember when we talked about checking things? It didn't keep checking. So it can't get better. It can't improve. So it doesn't adapt over time, right? People use it without asking questions. People who are authorities who use Compass don't really know how it works, and they don't ask questions about how it works, and they just kind of blindly believe whatever the score comes to them. And that's including whether or not this is the right place for an algorithm at all. Usually judges make that kind of sentence. It might not be the place for an algorithm to decide these things. The thing about machine learning is it can really only evaluate the past. It can't predict the future. We try to use it for predictive associations, but it can really only see what's already happened. So if you're interested in learning more about this kind of stuff, Weapons of Mass Destruction is a really, really cool book. I don't like the idea myself of Compass being the sole evidence that a decision would be based upon. This is a quote from the guy who made it. The guy who made it doesn't really want it to be used this way. So Brennan didn't actually build the technology with the idea of the use for sentencing. But that's the strange thing about some of these technologies. And if you're familiar with open source projects, or if you do open source, you might know that if you put code out into the world, people use it for all sorts of things that you might not have intended. So we really have to start asking those questions, and us as technologists being responsible for some of those questions. So it's critical for these technologies to not only be transparent, but also be reevaluated in order to not be abused. They can't be magical. People will say algorithms can't be biased, but algorithms are written by people. So this doesn't just happen to criminals, this happens to all the tools that we use to live online today. So Axiom, a data brokerage, had an average of 1,500 data points for 500 million consumers, including the entire adult population of the United States. They had data on all of us. And that was in 2012. And that was just one company. So people are constantly collecting data on us, no matter who you are, no matter what you do, if you're living your life online, which almost all of us are, right? Probably everybody is. So I used a Chrome extension called What Does Facebook Think About Me to kind of figure out how I'd been tagged by Facebook's algorithms and to see what they thought I liked and what they're using to kind of target me. So some of these things are kind of obvious, and like if you follow me on Twitter you would know, like I like dogs, I like cloud computing, I like wine, I'm a software developer, kind of, you know, normal for me things. And then there's some strange things like trench coat. I'd never worn a trench coat. Mermaid, I'm not sure where mermaid came from. I don't knit. I've never read a James Patterson book. I wasn't in the Navy. So some of them are kind of, you know, laughable a bit. But the problem is that Facebook uses these tags to drive directed ads, and it can use that to target on demographics, and that includes race. And what's interesting about that is that you can actually buy a home using ads on Facebook, and then they're targeting based on demographics. And that's actually illegal in America under the Fair Housing Act of 1968, because you're not really supposed to say only a certain kind of person can live in a certain location. That's wrong. So once that was pointed out to Facebook, they fixed it. And I think that that's a really important part of this, is that there's always potential for us to not foresee some of these conclusions. Hopefully you're hiring a diverse team, and that really does help. You know, someone can be on that team and say, hey, you know, as a woman, this doesn't make a lot of sense to me, or, you know, having people represented from different groups. But what ends up happening is that if you don't have a diverse team, you can kind of lock yourself into this. So Facebook fixing it is a big deal. But another key problem with this, and you might have noticed it, is that you don't tell Facebook your race. It's guessing your race based on ethnic affinity by the same algorithm that thinks I'm into mermaids. So this is something that also can be wrong. So the issue of what you're seeing on a day-to-day basis is that a lot of it is filtered. And that filtration system can be fallible at best and illegal at worst. So it means that you're seeing studies and educational materials based on what you already believe. So that's a lot like that patrolling system. It can be a self-fulfilling prophecy. I've also personally seen this. At one point I worked at a company who was starting to introduce machine learning. They proposed an idea to surface content based on different demographics area. And I had just read about that particular use case about that weekend, namely that it wasn't legal. And I brought it up, and people in the room realized, oh yeah, like we looked it up and yeah, we're not allowed to do that. Okay, that would indeed foster bias. But I was just an ordinary engineer on the project. I wasn't a PM. I wasn't in charge of the direction of it. I was just supposed to be there for implementation. But ordinary engineers can also say something. If you see something that doesn't seem right, it's important that you raise your hand. Otherwise, we would have shipped with really negative consequences. It's not that digitizing the world is inherently bad, but the more technology becomes embedded in all aspects of life, the more it matters whether the technology is biased, alienating, or harmful. And I had this brilliant coworker who just left my company. I'm sad about it, but her name's Paige Bailey. If you don't follow her on Twitter and you like machine learning, you should go follow her. She's a genius. These tales are pretty dark, but machine learning offers a lot of amazing benefits as well. So as my brilliant ex-coworker Paige says, it's like the risk we take every time we get into cars or airplanes. They've completely transformed every aspect of life and made so many things possible that wouldn't have been possible, that would have been impossible before, but they're inherently dangerous and can be seriously misused. You can kill someone with a car. You can use a plane to kill a lot of people, actually. But so we put in safety precautions where we can. We set up street lights, and we reevaluate airbags and things like that. And we need to do the same thing with the technology that we use. Okay, I bummed everyone out. I'm sorry, it got very dark. I promise I'm bringing it back up, and we won't feel like that for the rest of the talk. So let's explore some really cool applications for machine learning and what we can do with it. So as I mentioned, I work for Microsoft, and in Azure we have a thing called cognitive services. Sorry. Need a little more. Called cognitive services. There's a specific API called the Emotion API, and what it allows us to do is analyze things like pictures and videos and check out the emotions that it thinks it sees in those. And so it could be used to do things like this, which I built with Three.js. And might not have any other use case aside from entertaining my 4-year-old stepdaughter. Wow. Yeah, there's stuff up there, huh? Okay. Which can actually be pretty magical too, to tell you the truth. But what if we put this to more useful use? So I was mentoring a blind woman, and she mentioned to me that she found it very difficult when she was scrolling through Twitter and people were using images to have conversations with each other with like memes and things. So she saw this on social media sites and news sites and even just people talking to each other, and they don't include alt tags for any of the images. So I used another cognitive services offering, computer vision API, to create this, which not only analyzes the photo, but any text inside the photo. And then it applies alt text to whatever you see there. So here you can see the alt text is being printed above, but really what it's going to do and generate using Vue.js is apply the alt text directly to the image. So let's dive into some code. So if you haven't worked with Vue before, this is how we're calling the method on the component. That @ symbol is basically how I create an event, and I'm going to call that file upload method right on that component. So that's the file upload method, and we're passing in the event with that E. So you get the image from the user, and we're going to store it. And the new image, new file reader, that actually is a native API. That's not part of Vue. So you can see here that we're using Axios to call the computer vision API, and we're going to ask Azure's cognitive services to analyze the image. So it's really kind of cool. You just throw the image at this API, and it returns this blob of JSON that gives you what it thinks things might be, and kind of also like its confidence in it. It can also tell you like, I'm actually not really sure. Like, here's what I think, but kind of low score. So you can get a really detailed analysis without diving into all the internals of machine learning if you want to play around with it too. So we're using Azure Cognitive Services to analyze the image in two different ways, like I mentioned before. One way is to see what the image contains, and one to check for text within the image, and then we'll dynamically add the alt text to the image. So I'm only showing one here for clarity, but this demo is open source on my CodePen profile if you want to explore the code. You can also fork it. They told me, like, you shouldn't be leaving your API key open. I'm like, the purpose is for people to learn this, so we'll have to just deal. So you can explore that code. And now that that's built, I'm creating a Chrome extension so that blind people can use it on any site that they go to, and it will add the alt text to whatever image they see. This application of machine learning can help bring more people into the conversation and broaden our reach. So it's not perfect, but it's headed in a good direction where all of a sudden people who are left out of the story can now be part of it. So that's the amazing thing, is that by being inclusive, you're actually meeting business goals. You're not excluding the people in the center, you're bringing more people into the conversation. There's all sorts of really cool things that happen in ML for research too. So Sophia Genetics is training algorithms to diagnose diseases through DNA analysis, which is really awesome. All for Cure is a social network for cancer patients where patients enter their diagnosis and treatment so that it can be analyzed. It's really hard for doctors to, treat everybody and see everybody and write up every report. They, can only see a specialized amount of patients. So by building this social network that analyzes everybody, not only do patients kind of support each other going through treatment, it also is figuring out which treatments are being more effective than the other across the world, and it can analyze that on a grand scale. My husband has cancer, so that one I'm super into. And Health Map algorithm spotted an Ebola outbreak 9 days before the World Health Organization. This one is super cool, so let's dive into it just really super briefly. If you think about 9 days, that's an incredible lead time for an outbreak. Outbreaks grow exponentially. So by using machine learning in this case, the amount of people who are affected adjusts by a huge amount. So that's really amazing. Some of the things that we can do with ML in medicine is really cool. So what can you do? You might be saying to yourself, this is all well and good, but I'm not a data scientist and I don't work with machine learning. But that's okay. This subject matter, how we use technology for the world, is very broad. So it doesn't necessarily have to be machine learning. Let's talk about some of the things that we as web developers, there's all sorts of developers in this audience, but I'm going to use web developers as an example because I'm a web developer. So using something that we already know, that's not necessarily machine learning. So we work every day on building applications for good for different use cases. What if we thought about using some generic tools for a different cause? So there's a firehouse near where I live, and they have some sufficiently complex ways to make sure that everything is online and functioning, and that people are able to communicate. So I went out to their station to learn how everything works and see if I could do anything to help. So when the fire truck goes out, it has to communicate with a dispatcher, and that helps facilitate if they need more water or more supplies or some backup. And the app is very simple, purposefully so, because they want everybody to be able to use it really quickly and be able to see it with a push of a button, right? It's not meant to be beautifully designed. They want people to be able to activate things in a crisis. But I asked a few questions, including what happens if they're suddenly offline? What happens if they can't communicate? Right now, it just fails. They're hosed. Get it? Fireman, hosed. All right, I promise that's the last dad joke. So here's our opportunity. So we'll create a really simplified version of their app, preserving the basic layout, but I made use of service workers and background sync. So that allows them to alert them when they're offline so that they know immediately that they're not able to send anything. And when they're offline, it will queue the messages. Then when it's back up, it sends them out, even if they close the browser tab. Even if they happen to leave the application for a minute, it will still understand what happened. So here's what it looks like. You can see if I open the console, if I hit water, the sync registers and we sent a message. Now I'm going to turn off Wi-Fi, and now it says I'm offline and it alerts me at the top. Now I'll close that one out. and start it up again. Now if I open the console, it still has what we did, and we turn it on, and it's sent. So even though I closed everything out, you can still see that it, registers and goes forward. So that's pretty cool. Let's talk about some of the code. In order to alert them when they're offline, we're going to add an event listener to the window when VM.is online or is offline is actually a native JavaScript, is in the native JavaScript spec. So if it's online, we're going to say you're clear to send, and otherwise we give them this kind of error message. We'll register the service worker when the request is made, and the service worker isn't a normal function. So if you're used to working with JavaScript files and adding things in methods, it has to be in a different file, and it's a little like communicating with a server. You're kind of throwing things over the wall at it and finding a system to throw communication back over. You can't communicate with it really, really simply like you're used to. So if you have ever played with service workers and been like, why isn't it working? That was something that actually tripped me up when I first started working with it. So we're also going to pass in the type of event that was triggered so we can submit or queue what the user has requested. And not shown here, we're going to do some error handling, especially if the browser doesn't support the feature. So after we've activated and installed the service worker, we're going to strip out the type and pass it into a function that will process a fetch request whenever it gets connectivity. So as soon as it gets connectivity, it's going to send that out. So you don't have to worry about that task anymore. The service worker is going to handle that. So in that function, we're going to fetch a URL, a placeholder server in this case, and we're going to check if the response has happened. Once it has, we'll send a message back to the client with post message, and we'll send the response for the type of resource that we requested. Then we can alert the user that the request was finally sent because we want some feedback that it actually did go okay. But the most important part of this demo wasn't actually the application, and that's not why I was showing you. It was where we started. We started by asking questions. I went to the firehouse and I asked questions and I listened. And there were times when I felt like I probably didn't have anything to offer. That maybe they just had everything sorted and there was nothing I could build for them. But by asking what happened in every given scenario, we eventually arrived at a failure scenario that they could use the help for. And actually, now that I've deployed this, a couple of other people are using this in other firehouses in different areas of, I think it's Denmark that they're using it. So we have to ask questions. We have to ask questions at the beginning, like the Firehouse app. We have to ask questions once it's deployed, like the pred poll, just like in the criminal scores. We have to keep evaluating where these systems are going to make purposeful decisions to help people and to course correct when they don't. I see a lot of tech that asks questions about how to make our lives more comfortable, which I appreciate. On the weekend, I build stupid stuff, and I made myself a cocktail finder. So that's fine. But I also see a disproportionate amount of projects that focus inward rather than outward, focused on serving people with money rather than asking what people might need help. And there are a lot of opportunities out there to help. You probably already have the training to make some of them. So it just takes a little imagination and exploration, but it can really pay off. So what I want you to think about going forward is this, that I really do believe that programmers, us in this room, are some of the brightest minds of this generation. As you build these applications for the web, you're also building the pillars and blocks that our whole society rests on now. You're crafting the shape of our digital lives. This could mean building new features. This could mean advocating for accessibility. This could be as simple as raising your hand when something just isn't right. It's not just your job to create projects and do as you're told. It's also your job to ask, are we building things correctly? Are we building the right things? And are we building them well for all the digital lives that we touch? Thank you. I can take questions if you want, or we can just socialize.
I have a question. About the firehouse thing, how did that come about? Did you just approach them, or is there like
Yeah, I just found their email and started emailing them. And I think they were pretty confused when I first started messaging them about what I was intending to do. But we got past that, and I ended up having a great time meeting them. So yeah.
Oh, that's very cool. Thank you. Any other questions?
Yeah.
As a developer, also are interested in machine learning. How, like,
Where is the entrance? How can someone start?
Yeah, so the cognitive services that I just showed you, they have a free tier. So basically, if you're a web developer, you just make a request to the API. I shouldn't say just, I'm trying to break myself of that habit. You make a request to the API, and then it gives you a blob of JSON back, which actually says all of those things. So for the emotion API, I didn't show code for that one, but I could take a picture of somebody in this room, send it to the emotion API, and it pings them. They analyze it, and then it comes back and it will say, like, if I'm smiling and they can see teeth and stuff, which is part of the way that it evaluates, it'll say, happiness, like, likelihood is 0.9. So they have, and then sadness, 0.002, or it'll give scores and ranks for each one of the kind of main thought, like, emotions that you might think of, and you take the highest one. So you just, you can traverse that data and then find the highest one and say, then you can do whatever you want with it. I have a friend or someone on my team made this emojifier where you can send the image to the thing and it will apply the emoji to your face because it also gives you the rectangle for where that coordinate is. So you can make all sorts of stuff with it. Yeah.
After finding the flaw in Compass, are they still using it?
Yeah, I think that they are. I don't think that Predpol or Compass have been taken down yet, unfortunately. But hopefully, if we keep saying stuff about it, they will. Okay, let's socialize.
Okay. Thank you so much, Sarah.
Thank you. Thank you.
So now we have some time to hang out, talk to the speakers, ask questions, network, talk to each other as well. And yeah, enjoy. We have some time. Get some drinks and enjoy. Thank you everybody for coming. Thank you.